So this is lesson 15 in Algebra 1, surface area, and I'm going to call this 15A. It's very possible that we will need a couple videos for this. But this is some of the geometry side of Algebra 1, and you'll also get some geometry in Intermediate and Algebra 2 as well. And these things are called geometric solids, and they're called geometric solids because they're three-dimensional. We have a length, a height, and we have a depth here, so it's 3D. And geometric solids whose sides are at right angles with the base. Here's the base right here. And the side is a right angle with that base. When that's the case, it's called a right prism. Now I can also have a box here like this. It's also a right prism if my side is perpendicular to or makes a right angle with the base here, which it does. So that is also a right prism. So the surface area of a geometric prism, let me get rid of that because I like the box I've got here, the triangular thingy I've got here better. So the surface area is all of the, well, let's say that you're making this out of cardboard. It's going to be all the cardboard it's going to take in order to make that. So we've got this part right here. We've got this triangle right here. And let's see if I can make this a little bit bigger here. And on the bottom, if we show a dotted line here, there's hidden lines back there. We've got a base, don't we? That's on the bottom. And then we've got this corner here. It's going to come down. Okay, so I don't know if you can see that or if it just makes you dizzy, makes you want to throw up looking at it. But those are the backs. So what we've got here, we've got the angled part right here. That's one area. We've got this back triangle right there. We have the back, which in this case is a rectangle. We have the bottom, and we have the side. So for this particular triangle, we have 1, 2, 3, 4, 5 different sides. 5 different sides to this. So in order to find the surface area of this, we have to find the area of each of the pieces. So let me go ahead and erase the pink and erase the 5. Make this smaller again. Kind of move it up here. And so we have 5 different sides. So let's find the area of, first of all, this part right there. And it's going to be 5 by 6. So we'll call that the, well, I don't know what we would call it. I guess we would call it the area of the front. We'll call that the front. And see if I can erase it. There you can. Alright, so that's the area of the front. And we're going to add this triangle here, which is 1/2 base times height. Okay, so that one's done. We're also going to do the back of that, which is going to be the exact same. Okay, so we've taken care of 3. This one, this top, and then the back half triangle. Now let's do the bottom. The bottom would look like this underneath there, and it's 3 by 6. Okay, so there's 4 of them. The only one we have left to find then is the back, and the back would be this line down here and this line here, because there, that would be, so this would be the back. And that back then would be, let's see, it's going to be 6 wide and it's going to be 4 high, so it's going to be plus 4 times 6. Alright, so then we multiply all this. 5 times 6 is 30. Whoa, that doesn't look like a 30. It's pretty cool though. 30. 1/2 times 4 times 3. So half of 4 is 2 times 3 is 6. This is the exact same thing. 4 times 3 is 12. Take half of that. 6. 3 times 6 is 18. 4 times 6 is 24. Add all this up, and there's 5 of them because there were 5 sides. We've got 36 plus 6 plus 18 plus 24. 42 plus 18 plus 24. 60 plus 24 equals 84. And we're done. So let's see, example 15.3 says we have a right circular cylinder, and again it's right because it's a 90-degree angle with my bottom there. Alright, so we have a right circular cylinder. It has a radius of 4 and a height of 10. Find the surface area of the right circular cylinder. Okay, surface area is like how much aluminum is it going to take to make this pop can? So what we have to do is we have to find the area of the bottom, the area of the top, and then the area of this. This is called the lateral surface area. So we've got to find all those areas. Now the area of the top and bottom are pretty easy because we know the area of a circle is pi r squared. So that would be pi times, we know radius is 4 squared, so that's going to be 16 pi. And we have 2 of them. So we have 16 pi plus 16 pi. And we've got the 2 bottom ones there. And the book uses 3.14 for pi. Okay, so that's the 2 of them. Now we just have to worry about the side. So what we're going to take with this side here is we're going to take a pair of scissors and cut it right down there. And then what we're going to do is we're going to lay it flat. So we just unrolled that after we cut it down that white line. Well, how high is this pop can? We just said it was 10 because of this right here. Now we have to find out how long it is. Well, we know the length of it is, and I'll do it here in red, from here around back here again. So that would be this length right there. Well, that's called the circumference. And we know the circumference of a circle is 2 pi r, or 2 times 3.14. And what is the r? The r is the radius, which is 4. And if we multiply all that together, this here, we will get the length that goes right there. So let me do that real quick. So that is 25.12. So we have that, which is the length right here, 25.12. Alright, so let's take everything that we've got so far and figure it out. Well, first of all, let's multiply 10 times this in order to get the area of that. So that would be 250.12. Now you'll notice that my answer is going to be a little bit different than the book's just because of the way I did pi here. I averaged it, or I estimated it differently, but it's okay. As long as everything's done right, you can be a little bit off on this, and it all just has to do with what you did with pi. I accidentally pushed, I think, the pi key on my calculator instead of taking 3.14. Alright, so that is the area of the vertical part. These are the areas of the circle, the top and bottom. So now we're going to add all those together in order to get the total surface area. So what I'm going to do is I'm going to add the bottom area, the top area, and the lateral surface area here. So I'm just going to add those together. So if I take my 16 times 3.14, I'm going to get 350.24 here, and 50.24 there, plus 250.12 from here. That's a point. And so this, when I add those, let's see what I get here, 250.12, and that gives me 350.6. And the book got 351.68, so just a little bit off, and again, that was just because of the use of pi there. And gosh, I kind of made a mess of that one. Stuff all over the place. Let's see if on this next one I can do it in such a will be neater. So this is example number 15.4. So this part right here is the top and bottom. They just kind of made it bigger here and so they could put the numbers in there. But this is the shape, and this is the top, and this is also the bottom. So we're going to find the area of the top and the bottom, and then we're going to find the lateral surface area, this part here that goes around here, and then this back part right there. So let's get started on that. So finding the area of this thing right there, we're going to first of all change our color. So we're going to find the area of this box and then the area of this half circle. So, because I know how I can find the area of a rectangle and the area of a circle, but this thing by itself can't do it. So 6 times 5 is the area of this. And the area of a circle is not C, A equals pi r squared. So pi is 3.14. And the radius is 3, and we're going to square it. So we have 3.14 times 9, and that is 28.26. And this is not a full circle. It's a half circle. So we're going to have to divide that by 2 in order to get a half circle. So that ends up being 14.13. So we have 14.13 right here, and this one is 30. And when we add those together, we get 34.13 for the total area of this base. And we also have the top. So the base is 34.13 and the top is 34.13. So we're going to have to add those together. Now we're trying to find the side. And again, what we're going to do is we're going to take this thing and unravel it so we can see exactly how long it is from here all the way around to here. Well, I know how long it is from here to here. It's 5, and from here to here it's 5, and from here to here it's 6. So if we were to undo this whole thing and make one long line like this, from here to here is 6. That would be this distance. And then we've got a 5, so this is 6, this is 5. And then we also know this up here is 5. What we don't know is this distance here. So now we're looking for the circumference of that circle. So let's see if we can get rid of that so that we can look for the circumference. Circumference is 2 pi r, or 2 times 3.14 times 3, which is 6 times 3.14. And 6 times 3.14 is 18.84. But that's the circumference of a circle. And again, we've got a half a circle. So a half a circle is we take half of 18.84 and we get 9.42. So this line is 9.42. So when we stretch this whole thing out, it's going to look like that. So if we add up all those sides, we've got 6 plus 5 plus 5 plus 9.42. And that whole line then is 25.4, come on, 0.42 long. From here to here. Alright, but we didn't find the area, we just found the distance from here all the way around to here and over. Now we have to multiply that by the height, and that will give me the area of this. The length of this whole thing times the height. And the height is, according to the book, 10. So we're going to take the 25.42 that we found up here, multiply it by 10, and get 254.2. Then we're going to add this whole thing up. So when we add these up, we've got 34.13, 254.2, we add those all up, and we get 322.44 for the area there. And that's it for problem set 15, or lesson 15. We'll do problem set in just a minute.